Hello everyone. Today is going to be the last day of notes in chemistry ever. I want to finish up this chapter on chemical reactions. There's three more types of chemical reactions I want to talk about, and then we're just going to learn how to identify different ones. Okay, so a single replacement reaction, also called a single displacement reaction, is where one element reacts with a compound and the single element replaces another element in a compound. Okay, so the general format for these types of reaction is A reacts with BC to form BA and the C. So if you look closely, you will see that the A and the C just kind of switch places. A is an element, and it's reacting with BC, which is a compound. A and C switch places, so it's called a single replacement because one element replaced one element in a compound. So the reactants, you always are going to have an element reacting with a compound, and the products, you're going to have an element and a compound. It's just going to be a different element and a different compound. Now, if you guys are taking honors chemistry, you're going to take AP, you will learn how to determine what element replaces what other element. It's based on something called the activity series. The higher the element is on the series, the more reactive it is, and the more likely it will replace another element in a chemical reaction. Okay, so let's write a couple examples. Potassium metal reacts with sodium chloride to produce sodium and potassium chloride. Okay, so the reaction, potassium metals K reacts with sodium chloride, NaCl, and it produces sodium and potassium chloride. If you look closely, the sodium and the potassium just basically switch places. The two metals switch places with each other. So if you want to see it visually, just think of the two ions switching places with each other. Now, I had to make the potassium a positive cation because it's now attached to the negative chloride ion. And the sodium is now just metal. It's no longer an ion. Okay, now zinc reacts with copper 2 chloride to produce zinc chloride and copper. Okay, so first let's look at it visually. You see copper 2 chloride is the compound and zinc is the element. When they form a reaction, the zinc and the copper just switch places with each other. Okay, so the reaction is zinc reacts with CuCl2 to form ZnCl2 plus Cu. Again, single replacement, one metal replaces another metal. Now, it could also be a non-metal replacing a non-metal, but both the examples I've shown you so far have been a metal replacing a metal. Okay, another one. The interiors of pennies are made of zinc. If you take a penny and you put it into hydrochloric acid, you'll get a reaction. The zinc reacts with hydrochloric acid to form zinc chloride and hydrogen gas. Okay, so in this case, we actually have a metal replacing a non-metal. So in this case, zinc plus 2HCl forms zinc chloride, ZnCl2, and H2. I already balanced it for you. So if you notice, the zinc replaced the hydrogen in the compound to make zinc chloride. And it's H2 over here because hydrogen is one of those divalent compounds. Okay, now the fourth type of chemical reaction is called a double replacement reaction. It's the same thing as a single replacement reaction, except we have two elements replacing each other in a compound. So I want you guys to always, I'm going to put in perspective of the cations, which are the positive ions, generally the metals. So think of two metals replacing each other in two different compounds. So it's double replacement because two things are going to be switching places instead of one. Okay, so the general form is AB reacts with CD to form AD and CB. So if you look closely, the B and the D just switch places, or vice versa if you want to think about it, the A and the C switch places. It doesn't matter which way you want to think about it, it's the same thing. So you always start with two ionic compounds, like salt, and you're going to end with two new compounds. Sometimes they're ionic, sometimes you could have like water or covalent compounds like that. Okay, so let's look at an example. Sodium chloride reacts with silver iodide to produce sodium iodide and silver chloride. So let's look at it visually. Look at the sodium and the silver. I just dropped them down. Now I'm going to take the chloride and the iodide, and they're going to switch places. Double replacement. So sodium chloride, NaCl, reacts with AgI, which is silver iodide, to form sodium iodide and silver chloride. So again, just think of the two metals switching places or the two non-metals switching places. Okay, next one. Sodium chloride reacts with magnesium iodide to form sodium iodide and magnesium chloride. Again, let's do the same thing. I'm going to drop the metals down. I'm going to switch the ions. Now, the difference here is magnesium has a positive 2 charge and sodium only has a positive 1 charge. So if you notice this time, only one of the iodides moved over to the sodium, and I had to add an extra chloride to the magnesium over there. That's the whole point of you guys balancing chemical reactions. So the reaction comes out to 2 NaCl reacts with MgI2 to form 2 NaI plus MgCl2. Okay, last one, magnesium oxide reacts with calcium sulfide to produce magnesium sulfide and calcium oxide. Again, this one is just a straight, just switch the two nonmetals and you got your balanced reaction. We didn't need to add any coefficients. MgO plus CaS forms MgS plus CaO. Okay, and then the final type of reaction is called a combustion reaction. This is the type of reaction you guys are all familiar with. This is what you guys call burning. Okay, so this is where a hydrocarbon, which is things that are made of carbon and hydrogen, react with oxygen, and they produce heat, light, by releasing energy. So we, again, call this burning. Okay, so the format of the reaction looks different than all the other ones. So the format is CXHY. The X and the Y are just numbers. I'll give you a bunch of examples in a second. So it could be like C2H4 or CH4. So the X could be just a 1 or 2 or 3, and so could the Y. Okay, then it always reacts with oxygen, and they always form carbon dioxide and water. And I put energy, which is the heat and the light that it releases. Now, I said that always forms carbon dioxide. Sometimes you get what's called incomplete combustion reaction. It forms carbon monoxide. That is not the goal, but it does happen sometimes. So your reactants are always going to be oxygen reacting with a hydrocarbon. So a hydrocarbon always has that formula CXHY. And sometimes they also have oxygen in them, but the examples we're going to look at just are made of carbon and hydrogen. Your products for this class are always going to be carbon dioxide and water. But again, carbon monoxide is a possible product. Okay, so let's look at an example. Methane gas reacts with oxygen to produce carbon dioxide and water. This is the reaction that happens in the Bunsen burner. Natural gas is mostly made of methane. So CH4 reacts with 2 oxygen gases to form carbon dioxide and 2 water molecules. So whenever you guys burn something like wood, other than the ash and the little bit of smoke that's produced, the stuff that you burn like wood and paper turns entirely into gases, carbon dioxide and water. Okay, another one, propane gas, like if you have a grill at home, you have a propane tank probably, reacts with oxygen to produce carbon dioxide and water. So propane, C3H8, reacts with 5 oxygens to produce 3 carbon dioxides and 4 waters. I already balanced it for you, but if you notice, the reactants are the hydrocarbon and oxygen, and the products are CO2 and water. Okay, last one, octane gas, which is the main component of gasoline, reacts with oxygen to produce carbon dioxide and water. Oops, sorry. So again, just the hydrocarbon, so 2C8H18 reacts with 25 oxygens to form 16 carbon dioxides and 18 waters. It's already balanced for you, but the main goal is that you guys can identify this is a combustion reaction just by looking at it. Okay, so there's the format of all of them. Let's just do a couple examples. Okay, so I want you to identify each of the following reactions just by looking at the type. I'm going to read you the answers, then I'll put them all up on the next slide. Okay, so if you look at the first one, you start with a compound and it breaks apart into 2 compounds. Since you're starting with one thing and you're ending with 2, this is called a decomposition reaction. Okay, the second one, we have an element reacting with a compound. If you look closely, the metal, sodium and calcium, are just switching places. So it's one metal switching place with one metal. So that is called a single replacement reaction. Okay, number 3, we have CH4 reacting with oxygen, forming carbon dioxide and water. That's a stereotypical combustion reaction. Hydrocarbon and oxygen forming carbon dioxide and water. Okay, number 4, we have 2 ionic compounds forming 2 new ionic compounds. If you look closely, the 2 metals switch places, or if you want to look at the other way, the 2 nonmetals, the nitrate and the chloride, switch places. So 2 things are switching places, so it's a double replacement reaction. Okay, and then finally, we have 2 elements combining together to form a compound, so that is called a combination or a synthesis reaction. So there are your answers. Okay, lastly, I'd like you guys to try the review questions. Just real quick, I want to get you guys started. I'll give you the answers for the first 5 of them. Okay, so the first one asks you to identify the decomposition reactions by circling the letters. If you look closely, A, C, and F all start with one compound, and you end with two or more new compounds or elements. One thing breaking apart into multiple. Okay, second one asks you to identify synthesis reaction, which is the opposite of decomposition. If you look at C, E, and F, you will see that two or more things on the reactant side combine together to form one new compound on the product side. Okay, 3 asks you to identify the single replacement reactions. Again, if you look at C, E, and F, you will see one element is switching place with the element in a compound. So those are called single replacement. Okay, 4 is the double replacement reactions. If you look at B, D, and F, you will see two compounds reacting on the reactant side. And if you look closely, you'll see the two metals will switch places on the product side. Okay, and then finally the combustion reactions. If you look at A, B, and D, you will see that they all have a hydrocarbon and oxygen on the reactant side and carbon dioxide and water on the product side. Okay, there are a few more review questions where I want you guys just to identify the chemical reactions, so use numbers 1 through 5 as your guide. Again, I want to thank you guys for this year. It's been a great year. I hope you guys learned something. If you guys have any questions on this or anything, please let me know. And don't be a stranger. Please stop by and say hi next year, since it'll have been like 6 months since I've seen you guys. Have a great summer.